Well, this is the big surprise. This is the big announcement I was gonna make. And guys, check this out. Huge power bank. Huge battery bank. This is ridiculously huge. And this is the Panasonic batteries I've been dealing with here. Let me show you. Yes, these modules here. I got 14 of them, and I decided to turn them to something else. And you guys seen I was doing the manual balancing, top balancing with my improvised BMS, and it turned out to be a monster. So 12 of them now in parallel. So if you can see all the interconnects, just like what I have here, positive to positive. So I have two modules in parallel. So this guy right here, this guy here. So it's like one battery, 2, 3, 4, 5, 6, like 6 batteries. But there are 12. I just wired them in twos in parallel. So you can see the little wires come to this, connect for the positive, sorry, for the negative, and the positive is up here. So you draw from different angles. So these are the wires. I end up having 3 on 6, 3 of the 3 on this slide from this side, and 3 on the positive as well. So I can have these 3 wires, put them into a bus bar, crimp them, put into a bus bar, crimp these guys, or I can do individual and put them into a bus bars. But I can able to double click. These are just 6 AWG welding cables, Royal Excellency or South wire. So number 6 right there. I don't know if you can see it. So I have 3 on the blacks here and 3 on the other blacks here. So it's 6, and reds 3 on these and 3 of these. So it's 12 wires. So it's number 6, and we're gonna be pulling, and this bank is just I think almost to 80 amp, but a 48 volt. But it's I think it's a 3.4 kilowatts, something like that. Let me check. I already print the labels for it, and let me show you what the label said. So it's a 48 volts. I just have to put the labels. 48 volts, 3.694.08 kilowatt hours of power. These are high voltage batteries. They can release so much power. And this way I use straps, and I strap these guys well. And what I did in between the panels or the batteries, you see, like you have like a styrofoam, something like that, but I end up using like cardboards because I don't want these BMS leads to come in contact with the top battery. I've seen it. I was gonna stack them with the rods. Okay, these rods right here, boy, it didn't go well. Just like the way you stack the Nissan Leaf batteries, but it's not gonna go well. They almost trying to keep on moving a little bit, sliding like this. And anytime you slide, these little fuses or connection for the BMS, like this guy right here, we tend to touch the side of the battery, which is this metal, and it will arc. To prevent fire or to prevent danger, I have to put a cardboard. I cut them, thin one like this. Then I place it underneath, overhang on the other side. And this is how I separated the batteries. I'm sorry because the camera is moving so fast. So you can see them in between. Here, see the cardboards in between? I have them all the way in between. When I came to sandwich the battery, I use a cardboard to separate the middle. The reason why I did is just because so that I can have a kind of damper, like instead of the batteries are touching each other, I'm trying to put a space in between them. Two cardboards here. You can see right in the front, right here. And I brought it all the way to the front to separate the terminals from any flint or arcing. Sometimes you can see like a little flames jumping from each other if the terminals are not tight enough. It arcs. So I do that so that for preventing any catastrophic thing from happening. This cardboard is in between. Well, it's better than nothing. Some people say maybe you shouldn't be using the cardboard there. But nobody has said that. I just mentioned that because I might probably heard something like that. But this is going to act like a stabilizer. The board in the middle, which is right here. Because I try to put them together, they don't just jammed up really well or come in close contact. So I put that one in between and gives me, when they hit each other now and they kind of stable, instead of rocking back and forth, they're not rocking anymore. So I use these straps I bought from the hardware store and strap them. Still I didn't even have the stability. I strap them across. I strap this across. So two horizontal, two pair vertical. Two vertical, two horizontal. And still the stability wasn't that firm. So I have to make sure I started using the Kempton tape, the heat protective tape. I started going to the side while the thing was standing, going back and forth to stabilize this thing before I come back on the back and started passing this one. So I left some openings here so that the batteries can breathe. I can able to put a fan on the back to cool the cells and blowing the heat all the way to the front or vice versa from the front to the back. So I have all the specification already printed. Then to patronize with battery hookup, I use their logo. I should have put mine there, but anyway, very good people. And I appreciate their business, and I just want to advertise for them as well so that people can see where I got these batteries, and you can use my affiliate link on the description below to buy batteries from them, and you can save 5% on your purchase. So this is the battery I've built, and you see the ends here, the straps, and I have two here remaining. I cannot put them here because it would have been awkward, like having one sitting on top of these. It's really hard to configure or wire. So 6 on each string. There's 2 strings of 6, and here you go. It's 48 volts, and it's a 13S 12p. That's what it is. That's why I created here. 13S 12p. So it's almost about 80 amps, 80 something amps, but these things can pull up to 100 amps continuous. So voltage is going to be 54.6 at 4.2 volts per cell. Each cell can release about 25 amps each cell, because there's a 18650 batteries in here, over 52 of them approximately. So they can release, each one can release about 25 amps. So if you discharge this pack, each pack of these, or each module, because 2 modules right now, you can pull 100 amps continuously. So these 2 guys are wired in parallel. These guys can pull maximum of 200 amps. That's what the spec says. So you can see the other little guy there. This is where the negative connected. Then I pull from there, and the positive is right up here. This one. So I use a 6 gauge, and the bus bar. I'm sorry, the terminals. I know. Here I don't have a heat shrink, and I'm not gonna change it. It's gonna stay that way because I'm not gonna dismantle the entire pack anymore. It's safe the way it is, but I'm not gonna take the pack or break it down anymore. I'm not doing that because of heat shrink. Now I already made the terminals, and I want to get this project done and move on to another one. There's nothing gonna interfere with this. You can see the Kempton tape is around there, and this is gonna go like in a box like, or it's gonna sit somewhere where it's gonna be running a 48 volts system. Stay tuned for that video. It's a clean setup here. These wires, I just fold them and put them this way. They would have been all the way up here. You see how nice it is, and the labeling is gonna be up here. I already printed all the labels, and there they are. And just about for me to do and put the ends. What am I gonna do with this to get maybe the bus bars, good bus bars, like a Victron bus bar thing, the block, and I can able to pull into this one and go to a shunt, and everything's gonna work out well. I want to put this thing into test. We already charged the batteries, balance them, bottom balance and top balance them. You guys have seen that video, and yesterday I made another video for the other machines. Well, this is how the packs are. If you can remember, this is how they look like, and I turned them to a monster. They might probably end up to with a dolly, and I don't know. I'm gonna put a casting wheels on them. It might. And here is another project right here. Like I said, I was waiting for these things, but I don't think these are proprietary. I spoke to battery hookup. I don't know if they have them. They're gonna contact the other guy. I think it's Alex. Ryan told me. I don't think this one's came with a whatever pack. So this is another one going on. It's a 8 modules here with their own BMS. It's a 4S configuration. 19 point something amps per pack. 18650. There they are. So this is the entire project. I hope you like. And don't forget to subscribe, like, and stay tuned for more to come live from the channel. JW Solar USA, live from Minnesota. Thanks for watching. Love you guys all, and stay tuned. I like this back. This is awesome. I put it side by side so that people can understand what I just did here. Thank you, Battery Hookup. Thanks for your help, and thanks for these batteries.